Hello students, I am Rashmi Vadwa, Assistant Professor of Sant Andrew Institute of Technology and Management. Student, today's topic is programmable interval timer, and this is the topic from unit number 4. What do you mean by programmable interval timer? Basically it is 82353 and 8254, and what is the need of this and what do you mean by 82534? Basically 8253 and 8254 both are a programmable interval timers and designed for the microprocessor to perform timing and accounting functions using 16-bit counters or a 16-bit register. Basically it includes a 3 identical 16 counters that can operate independently, and a 16-bit counter. To operate a counter, a 16-bit count is loaded in its register and on command, and it begins to decrement the count until it reaches to 0. And at the end of the count, it generates a pulse that can be used to interrupt the CPU. And each counter has 2 input pin, clock and gate, and 1 output pin, OUT. Basically, what is the need of 8253 and 8254 is that it solves one of the most common problem in any computer or in a microprocessor system, that is generation of accurate time delays under software control. If we want accurate time delays, so we require a programmable interval timers because counter lage hain. And instead of setting up timing loop in the system software, the programmable 8253 or a 54 both match our requirement and initialize one of the counter with the desired quantity. Then upon the command, we will count out the delay and interrupt the CPU whenever it is completed its task. So this is very easy for us. Software overhead is minimum and multiple delays can be easily maintained by assignment of priority level. So it is important for us. Basically both 8253 and 8254 both are programmable timer chip, but just 2 or 3 different features are here. 8253 operate a frequency from 0 to 2.6 megahertz. 8254 operating frequency is 0 to 10 megahertz. 8253 uses NMOS technology and it uses HMOS technology. 8253 is a read back command is not available, and in 8254 read back command is available. In 8254 read and write the same counter cannot be interleaved. In this the same counter can be interleaved. What are the basic features of this? इसके अंदर हम इसका आर्किटेक्चर कवर करेंगे, इसका पेन डायग्राम कवर करेंगे, एंड साइड बाय साइड इसके 6 ऑपरेटिंग मोड्स हैं उन्हें हम कवर करेंगे इस वीडियो में, मोड 0 टू लेके मोड 5 तक. कई बार पेपर में सिर्फ उस इसके मोड्स भी पूछे जाते हैं, तो इम्पोर्टेंट है मोड भी. कई बार आ जाता है व्हाट आर द ऑपरेटिंग मोड्स ऑफ 8253 और 8254, तो हमें ध्यान रखना है. What are the important features of 8253 and 8254 is the 3 independent 16-bit counter handle a DC voltage to 10 megahertz. 3 counter can be programmed for either binary or a BCD count, or it is a compatible with almost all microprocessor. And 8253 has a powerful command called read back command, and which allow the user to check the count value, the programmed mode, the current mode, and the current status of the counter. Now see its architecture. You can see in this architecture there is a 3 counter 16-bit counter. Each counter has a 2 pins, clock and gate, and 1 output pin out. So for clock 0, gate 0, out 0 for counter 0, clock 1, gate 1, out 1 for counter 1, and clock 2, gate 2, out 2 for counter 2. Read write logic is here, data bus buffer, control word register. So description of each block is necessary for the architecture. So first is a data bus buffer. This is a tri-state bidirectional 8-bit buffer that is used to interface 8253/42 with system bus. And the data bus buffer has a 3 basic functions: the programming modes, loading the count register, and reading the count values. And the important function of the read-write control logic is on 5 signals: A0, A1 address lines, read bar, write bar, and chip select. In the peripheral input output mode, this read and write bar signals are connected to read input output read and input output write respectively. This IOR is input output read, IOW is input output write. So in memory mapped input output, these are connected to ME, MR, ME, MW. जब आपका इनपुट आउटपुट मोड है तो रीड और राइट सिग्नल आपके IOW और IOR से कनेक्ट हो जाएंगे, और जब आपका मेमोरी मैप्ड इनपुट आउटपुट मोड है तो इट इज कनेक्टेड टू MEMR and MEMW. Address line A0, A1 are connected to the lines A0, A1 of the 8253/4. The chip select is tried to decode address, and the purpose of A1, A2 is to select the counter. If both the A1 and A1 and A0 is 00, then counter 0 is selected. If 01, then counter 1. If 10, then counter 2, and if both are 1, then count control word register is selected. What do you mean by control word register? It is a register which is assessed with the lines A0 and A1 at the logic 1, and it is used to write a command which specify the counter to be used, its mode, and either a read or write operation. And you know the three counters: 0, counter 1, and counter 2. So these counters are identical in operation, each counter consisting of a single 16-bit down counter, and the counter can be operated in either binary or a BCD or an input BCD, and its output gate and output are configured by as its input and gate input gate and output can be configured by the selection of modes stored in the CWR. The counters are fully independent, and the programmer can read the content of any of the three counters without disturbing the actual count in the process. So अगर मैं इसके ऑपरेशन का डिस्क्रिप्शन दूं, there is a two operation: write operation and read operation. For the write operation, a control word into the control register and load the lower order byte of the count in the count register and load the higher order byte of count in the counter register. So this is the format for the write operation, having a 8-bit format. D0 is a BCD. If this bit is 0, then the binary counter in 16-bit, and if it is 1, then BCD, binary coded decimal counter, is here. When D3, D2, D1, 3 bits for mode 0, mode 1, mode 2. When all are 3 are 0, 0, 0, 0, 1, 0, cross 1, 0, possible combination is there for the selection of mode 0, mode 1, mode 2, mode 3 up to mode 6. This is for the RW1 and RW0 is for read and write. When both are 0, then the counter latch command. When this is 0 and this is 1, then read write least significant byte only. When this is 1, this is 0, then the most significant byte only. And when both are 1, then the read write least significant byte first, then the most significant byte. And this is for the select counter SC1 and SC0. When D6 and D7 both bits are 0, then the counter 0 selection. When this is 0 and this is 1, then counter 1 selection. When D7 is 1 and D6 is 0, then counter 2 is selected. And when both are 1, then the read back command for the 8257. Now come to the read operation, and the cross is for the don't care condition. This is for the read operation when this is again 7-bit format. This is for count status, counter terminal 2, counter terminal 1, counter terminal 0, and D0 is 0, and D6 and D7 1. This is for the selector count 0, counter 1, counter 0. D0 is reserved for future expansion, and D4, D5 is for the count latch count of selected counter, latch status of the selected counter. Now come to the modes of 8253 oblique 8254. There's 6 operating modes are there. Make sure आपको इनके operating modes भी अच्छे से पता हो. Mode 0 is a interrupt on a terminal count. This mode is used to generate an interrupt to the microprocessor after a certain interval. And this process of decrementing the counter continues till the terminal count is reached and the counter becomes 0 and the output goes high and will remain high until it loaded a new count. And the gate signal is high for a normal counting. When the gate lows, counting is terminated and the current count is latched till the gate goes high again. Mode 1 is a programmable one shoot. It can be used as a monostable multi-vibrator. The gate is used as a triggered input in this mode, and the output remains high until the count is loaded and the trigger is applied. Mode 2 is a rate generator. Its output is normally high after initialization, and whenever the count becomes 0, another low pulse is generated at the output and the counter will be reloaded. Next is a mode 3 square wave generator. It is a similar to the mode 2 and except that the output remains slow for the half of the time period and high for the half of the time period. Mode 4 is a soft triggered mode, and in this mode output will remain high until the timer has counted to 0, at which point the output will pulse low and then go high again, and the counter is latched when the gate signal goes low, and on the terminal count the output goes low for one clock cycle, then it goes high. This low pulse can be used as a stop. And the mode 5 is a hardware triggered mode. This mode generates a stop in response to an extremely generated signal. This mode is similar to the mode 4 except that the counting is initiated by a signal at the gate input, which means it is a hardware triggered instead of software triggered. After it is initialized and the output goes high. When the terminal count is reached, then the output goes low for one clock cycle. This is all about the operating modes of 8253 and 4. Now the pin description of 8254. There are the three counters and a data bus buffer, read write control logic, and counter has a pin input, clock and gate, and one is output. See, it is a 24 input. अभी तक की सबसे कम pins मुझे लगता है 8254 में यही है. See, यहाँ पे 8 data pins हैं और अगर हम 3 pins काउंटर की काउंट करें तो 9 pins तो वहीं से हमें मिल गई. So 9 and 8 17 pins हो जाएंगी total, तो 17 and remaining are 24 ना. So remaining is 7 pins. So that is VCC, read, write, chip select, A0, A1 and ground. तो easy है pins करना इसकी. And what about these description of this pin? Data bus buffer. It is a tri-stated bidirectional 8-bit buffer which is used to interface to the data bus system, having a 3 functions. And now come to the read write logic, including 5 signals. And when A0 A1 is this, ये इसके architecture में भी explanation हमें यही follow करनी है. When both inputs are 0, then the counter 0 is selected. When 0 1, the counter 1. When 1 0, counter 2. 1 1, then the control word register, and don't care, no selection. And when it is an जब हम input output mode use कर रहे हैं, then read and write are signal connected to IOR and IOW. And when there is a memory mapped, then these signals are connected to MEWR and MER. Next is a count control word register. When these register is accessed with the line A0 and A1 are at the logic 1, then it is used to write a command word which specify the counter to be used, its mode and other read write operation. So when talking about the table regarding this register, 5 pins, 5 of pins I'm taking here. A1, A0, read, write, chip select. So chip select is active low, all are 0 pins. In half of the case, the read bar is active, and in half of the case, write bar is active, and correspondingly, A0 and A1 combination is here. When both are 0, then counter 0. When A0, A1, then counter 1. When 1 0, counter 2, when 1 1, then the count write control word. तो ये सारे write operation के लिए when write is 0. When read is 0, the correspondingly read counter 0, read counter 1, read counter 2. See from this table, यहाँ पर जब भी ये read operation 0 है, 0 है तो correspondingly read operation हो रहा है. जब write operation 0 है तो correspondingly write operation result हमें मिल रहा है. When it is don't care and both read and write is 1, then no operation performed. When both are don't care, then again no operation is performed. When this is both 1, then again no operation is performed. So control, सिर्फ ये कंट्रोल वर्ड रजिस्टर का भी फॉर्मेट इंपॉर्टेंट है. कई बार 4 मार्क्स में सिर्फ CWR भी पूछ लिया जाता है, व्हाट डू यू मीन बाय CWR. तो उस केस में आपको ये टेबल एक्सप्लेन करनी होती है. नेक्स्ट लास्ट एंड नेक्स्ट इज काउंटर्स. Each counter consisting of a single 16-bit counter and can be operated in binary and BCD mode, and its input and output is configured by the selection of mode stored in the CWR, and the programmer can read the content of any of the 3 counters without disturbing the actual count in the processor. So ये explanation आपको पिंस में भी देनी है, और अगर आपका आर्किटेक्चर आता है तो आपको आर्किटेक्चर में भी देनी है. So it's up to 82354 and 8254. In next video we will discuss next topic. If any doubt, you are free to ask. So thank you, students. Thank you.